So hi everyone, this is for this September monthly update. So this is the TGIP, and so for this month, don't have a ton of the updates. There were it was August last month, so many people were in and out of vacations. The announcement, I mean, it's not a new announcement, but it is something that we have been talking about for the past few months. There's going to be the Pulsar Summit Europe, and it's going to be held on the October 6th. You can go on the webpage, and there are all the session schedules are already available, and the keynotes will be announced very soon. So keep that on track and for October 6th. And I'm going to jump in directly on the topic for this month, which is the schema registry. So this is a feature that was introduced in Pulsar 2.0, and many people are using it, but we haven't really talked a whole lot about it. And there's a bunch of features that are very interesting, and they're very unique to Pulsar as well. So I'm going to use these occasions to expand a bit more and give more like a comprehensive overview of what the schema registry is, what it is used for, and what you can do with it. And so this is not really like a deep dive in the sense that I'm not going to talk how it is implemented, more like on how it works and how you can take advantage of it. So what is the schema registry? So the schema registry basically is a system that allows you to store information on the data structure. So what the data looks like, what are the fields of the data, what are the types of those fields, and make sense of it. And with this information, what we can do is that we can enforce the data types on the topic. So you can define that the topic has a certain data structure, and all the messages will have to conform to that data structure. And you will, basically the Pulsar will reject the messages that will not conform with that format. And at the same time, when you're consuming that from a topic, you might have some expectation that I'm consuming from this topic, I'm expecting this kind of data, and using the schema registry is a way to assert that, and so that you can avoid like runtime surprises when there are like changes in the schema. Another like key feature for the schema registry is to allow for compatible schema evolution. Like in the databases, when you set the format for your database table, that is a point in time, right? Many times you have to add columns, so add fields, or like change something, change the name, and so on. So basically, you're doing like migrations on your schema. You're slightly changing what your data looks like. And the key here is that we want to allow evolutions that are compatible with the data. And there's like a whole way to decide what is compatible, what does that mean, and so on. But basically, we want to allow the schema will evolve. That's always the case. Like you are deploying a new version of your application, and you have to basically make sure that both old client and new client be able to produce and consume data without any trouble. The other key aspect of the schema registry is that it supports for type save API. So if I'm writing a Java application, I can declare my Java class, and that basically it is definition of my schema. So it is tying the type safety, the serialization of these objects with the enforcement on the broker side. And finally, another important feature is discoverability. So I can ask the registry and say, give me the schema for this topic, what does it look like? Or I can consume data from this topic and receive messages and automatically figure out what are the fields. I'm not consuming bytes, I'm consuming data that has a type, has fields. These fields have name and value, and I can, like in a safe way, I can make sense of these fields and values. So if we just like a very shallow jump in here, is that the schema registry essentially it is a service that runs within Pulsar brokers. So it is a key integral part of Pulsar, and is not like any separate system that you have to deploy. This has two advantages. First of all, that you don't have to deploy another system. Second, that it is so ingrained in the data part of Pulsar that basically that allows you you're not going to be able to forget to set the schema on a producer, for example, like because that will get rejected. So it is not something that you have to check out of band. This is like when you enforce it, it will be everyone we have to conform with this schema, for example. And finally, like from a storage perspective, we use still BookKeeper, which we use for data and metadata as well for Pulsar. So we are using the same storage backend that everything is really used for. But yeah, all the interaction that producer consumer will have will be through the brokers. So the producer consumers are going to be passing us schema information, and this schema information, there are like few ways to declare that or to extract it. So for example, if you pass a Java class as a POJO, then basically we'll be able to automatically extract the fields for this class and derive the schema of this class. And then we can send it to the broker. The broker will validate that schema is valid and conformant. A different way is that you might have already some schema definition, for example, like Avro definition of schema that are used also in all other systems. So you can reuse that schema definition and use that as a schema declaration. So it's not extracted from the code; it is using that precise definition that you already have. We store the schema in BookKeeper, and finally there's a REST API. So you can use this REST API for like a management tool. So you can check the schema, retrieve the schema of a topic, or you can like update the schema, force to update the schema, or you can delete, like all these management operations. But it can also be used for like third-party applications so that they can integrate with the Pulsar Schema Registry and automatically discover the schemas for the topics. So that it can also serve as the backend for more general like schema applications usages. And what format we support? So far, we support these three formats: JSON, Avro, and protobuf. These are the most common format that we have seen out in the wild. And each of them has like advantages, disadvantages. Typically, people will tend to choose, companies will standardize on one format. So they tend to have like all the systems using one single format, which makes sense. You don't want to mix and match all the time. So typically, and a company that has standardized on Avro will want to use Avro. Someone that's standardized on protobuf will use protobuf, and so on. But if you look at it, just like a quick, very quick overview. So JSON is very dynamic, so it's good on that part. You can also like convert it, so it's also human readable, which sometimes helps. And it is not very specific because you have like all these field names that get repeated all over again, but it is very highly compressible. So yes, it is verbose, but it's highly compressible. Also, like the serialization tend to be quite fast. There are like many very optimized libraries to serialize and deserialize JSON. So that is not really a bottleneck or a problem. Well, if you look at Avro, so Avro has a very good way to define what are the mutations. So it is a more rigorous spec there, and also has already a way to declare the schema that many companies are using. These Avros, so it's a JSON string, JSON object that you can use to define your Avro schema. And that's what we use in Pulsar as well. So if you have already these Avro schema definition, you can reuse them so that you're not going to be relying on POJO extraction. Instead, you just rely on what you have already defined as Avro definition. The only drawback of Avro, I think, that is like the libraries and the serializer are not super fast. They're not super efficient. I mean, it works well, but there's like a bunch of object allocations all over the place. So it tends to be like a very CPU intensive, especially compared to protobuf and JSON. Again, protobuf can also be like a very allocation unfriendly. But the only thing for protobuf is that typically it requires, while in Avro you can have Avro generated code, or you can have plain POJOs that are not generated. In protobuf you have to have you must have these generated protobuf classes. So you have your proto definition, you generate Java code or C++ code or whatever it is. These are like very optimized for space and serialization speed. But the problem is that it kind of like limits a bit the auto discoverability because we cannot like make sense of what field names. So it doesn't contain the field names, for example. So we cannot if we don't have these class definitions. So it's a bit more involved in how to have like auto discoverability with protobuf. And what kind of use cases? So I kind of like briefly talk about it, but basically like the main use case that people want to have is that you want to prevent incompatible data to be published on topic. So you don't want that you have your topic, you're publishing some specific data, and you want to avoid that someone might have a bad version of the application that is sending data that is not compatible, maybe sending data that is garbage or in a different format or like a bytes or like instead of like where you're expecting a JSON. So you want to basically prevent any like either malicious or mistake that will cause your data to get your topic to receive the data that your consumer will not be able to make sense of it. At the same time, you want to have tight control on what migration you want to allow on your data. There are different reasons for having different policies. So we have a configurable way there to select what kind of migration do you want to allow. And let's say this is a kind of like service where we can discover all the schema information. That's kind of like a very important use case. And one example of it is Pulsar SQL. So Pulsar SQL is integrated directly with the schema registry. And that allows the Pulsar SQL is that you can do your SQL query in Presto TrinoDB, and automatically it will figure out what does this data on this topic will look like, and it will be able to extract the columns, which are the fields of your messages, and you can present those in a tabular way. So you can select and make filtering and so on. So, and this is all based on that integration component to be able to figure out what the schema is on the topic. So if we don't have schema information, we couldn't be doing these SQL queries, for example. And I talk about the type-safe API. So what does that mean? So type-safe API here is that we want to make sure that the producer, you can create a producer not just of bytes, but a producer of an object. With these, essentially, with this producer of an object, we are also taking care, the Pulsar client library is also taking care of the serialization of the objects, serialization and deserialization in the consumers based on schema definition. So the most simple way that you can do this is that you have your POJO object, this class person. I'm using Lombok here, but just like a plain POJO, and I'm creating a producer and I'm specifying that for this producer, I want to use a JSON schema of this person class. So that will basically trigger the extraction of the fields of this class, and it will compile a schema definition based on this particular version of this class. Tomorrow, I might add some fields and it will be a different version, but that happens organically, transparent from the user. So I'm declaring my producer with this person type. And then I can just send objects for it, and that will get serialized and published. And eventually, everything is published as bytes on the wire, so everything has to go down to bytes. On the consumer, like is very similar. So you are declaring your consumer of this again, and specifying JSON format and my POJO class definition, and then I can use that, and I can receive messages of person instead of messages of bytes. So then I can just get the value, and the value is my object instance. So when extracting the schema info, this is basically done through the libraries that we use for serialization. So it kind of depends like how you declare, but essentially like we are using Jackson for JSON extraction. So you can also use the Jackson like ignore or like kind of like annotation for Jackson in there. The other one is that on Avro, again, you use the Avro. We use the Avro own tooling internally, so you can tag your Avro classes with the Avro annotations to control like which fields get exposed, the naming, and everything that you would do with the Avro generally. So you can use the Avro own tools and own annotation here. The other possibility here is to just jumped ahead. The other way is to declare a schema programmatically. Essentially, like what you can do is like say if you don't have a Pojo or you don't want to use a Pojo, what you can do is that you can build programmatically a schema. So you have this schema builder class that you can use. You can call it schema name, but essentially you're creating your own type. And this type can have fields, field A, which is a string, and then field B, which is an integer. And then when you're done, you say, okay, build a build and say, okay, this is Avro. So I want to basically, I'm defining an Avro schema with these fields. With this, I can create a producer passing this schema from this schema info. And I get a producer of a generic record. A generic record is a way that you can have like these more less like use this to create arbitrary objects. So on the generic record, I can say on this producer, I have to pass. I can use like this schema new record builder. I can set field name and field value, and then I build and I get my message value. So I'm creating this generic object, and that this object gets. Since this was an Avro generic schema, it gets serialized as a Avro because we declare this schema info to be Avro. So this gets serialized into Avro, but I don't have to write a Pojo for it. I might not have access to a Pojo. I'm just like programmatically declaring the schema for this topic. In a similar way, you can use this auto-consume, and you can consume generic records. So auto-consume when consuming means that I don't know what kind of data is in the topic, and I don't care in particular. I just want to discover what it is in there. And essentially, it's kind of like a reflection here. So I'm not asserting that the data will have any particular format. I just want to discover and see what it is in there. So with this, I get a message, a consumer for a generic record. So when I get a message, you can say, give me the generic record. And with this generic record, I can go through the list of fields. And for each field, I can get the name, I can get the objects underneath, and so on. So I can like get all the list and discover what the message looks like. And this message could be a JSON, could be Avro, and so on. So it's it kind of like allows consumer or application in general to be very flexible and to be like generic in a way. Like for example, like when you're building some application that the same code will have to work with different topics and with different formats, this might be a good option here because this is not tied to a particular schema definition. Another way here is that, as I mentioned, that you might have already a Avro definition for your schema. So if you're using Avro, typically you're having this JSON definition of your schema. So it's kind of like an Avro format here. And this JSON object, this JSON string, contains the list of fields, the type name, and so on. So we can reuse that, and you also might have the Pojo class from Avro, so you can use these instead of relying on field extraction with Avro. So this could be like the precise definition of your data. So typically is the best way if you have it already to integrate. So you just pass, you create your arrow schema based on this JSON definition. Okay. And I talk about enforcement. So I say that the enforcement here, it is done by the broker. So you cannot escape that enforcement if it is set up. So if a topic has a schema defined, the broker will enforce the schema type. So you cannot consume entitled to publish bytes or incompatible data. And if a producer or consumer try to use an incompatible schema, they will get rejected when the session gets created. So there is no way that you can forget like an old application that is still trying to connect to the topic and publish some random data that will not be allowed anymore. So it kind of gives you the assurance there against mistakes. And some of the example here on how the enforcement is done, for example, this is like a very tiny example set, but just to give you an idea. So if the topic gets created, it has no schema information. So at this point, you may attach a producer, and this producer might require, say, I'm schema type Avro and schema info is based on my class version 1. So this is kind of like a POJ definition that gets extracted. So in this case, the outcome would be that the topic will get associated with this producer schema. So now the topic schema will become this Avro of my class version 1, and from that point on, everyone will have to conform with this schema. Similarly, like now you might deploy a new version of your Pulsar application, and this might have some field was added to this class. So now it is kind of like a different version of this class. It might be named in the same way, but it is like a different version because you added a field, so the schema extract it is slightly different. But if you determine that this new version of the schema it is compatible with the existing one based on the policies, then this producer will be allowed to connect, and the schema of the topic will be updated to the V2. So now the current schema to the topic will become V2. And in the topic, that would be coexisting this V1 and V2 for some amount of time. In a different way, like if you are setting this other class V1, for example, and that class is not compatible with the my class V1, the producer will get rejected. So it tries to connect, but no data will be allowed to be published on the topic because it is deemed incompatible. Okay, yeah, I have a fourth one. On the consumer, right? So consumer typically will assert that I'm trying to consume data with this format. If it's not true, consumer will get rejected. But consumer typically they will not update the schema of the topic. Rather, they just assert that what I want to consume has to conform with this schema that I'm declaring. But at the same time, a consumer might not care. I'm going to say, oh, I just want to receive bytes. Even though the topic has a schema, as a consumer, I want to receive whatever bytes are there. I don't care about schema. So that's an option. So this consumer will be allowed, even if it does not specify any schema. While the same will not be true for a producer. A producer will get rejected, but consumer will be allowed because it is not sending data on the topic. And finally, down to the enforcement policy. So there are few ways that you can define what is allowable or what's not. First of all, like by default in the broker conf, the schema validation enforce it is equal to false. That means that by default, broker will not reject producer with no schema. That was done for historical reasons, so that people were not startled when the schema was introduced. But for this stronger validation, you should turn that to true, so that at this point, the enforcement is fully enabled. And then there are like multiple ways to configure the strategy for the compatibilities that are allowed and what are not. So there's like a bunch of options here that you can configure in broker.conf, and also for namespaces as well. And if we go through the list, I'm just trying to, this is like a very short summary of it. It's not, the documentation is much more comprehensive. It has table with more in-depth examples, but like if you look at this, just to give you the gist of it. So you can say that the compatibility strategy is, like, say, always incompatible. That means that no changes will be allowed no matter what. So if your topic has the schema X and some producer tries to connect with a schema that is different, no matter what, that will get rejected. So you will not able to change the schema at any point in time on the topic. You can create a new topic with a new schema, but not on the old topic. Or you can have like always compatible. So always compatible means that you have to require a schema, but you can pass a new schema which is different, and that will get updated on top schema. So again, that's completely different direction here. At that point, you could also have like incompatible data that gets published on the topic with this setting. The other two are like more safer side. So you have the backward compatibility. So backward compatibility means that we are ensuring that only changes that preserve the backward compatibility of the data are allowed on the topic. And with backward compatible means that if you have, say, that you're going from V2 to V3 of a particular schema definition, the new consumer, the V3 consumer, need to be able to read both the old data and the new data, so both the V2 and V3 data formats. With these, we are only allowing changes to data format that will ensure that this property is true. So that will kind of like determine also like how we're going to be doing the upgrades. So typically, like, are you going to do like first the consumers or first the producers, or do you want to be able to mix and match with no particular order? So if you choose this backward compatible manner, means that you first have to deploy your consumers, and with the new version 3, and they will be able to read both V2 and V3. And at some point, you will be able to, when all your consumers are upgraded, now you can go and upgrade your producers. So it is kind of like you have to orchestrate that upgrade process. The forward compatibility is kind of like the reverse side. Essentially, like what you have the forward compatibility means that you can have old and new consumers, V2 and V3 consumers, and they both can read the new format. Essentially, what means is that in this case, you are going to first deploy your producers that will start to publish in V3 format, and then you're going to update your consumer. So it kind of like the reverse side of the process when doing upgrades. And if you combine these two strategies, you get the full compatibility. So full compatibility, it is a bit more strict in what mutations are allowed on the format, but when you have the full compatibility enabled, then you don't have to worry about which side I'm going to upgrade it first, because both V2 and V3 consumers will be able both to read both the V2 and V3 data. So at that point, you can do the upgrade in at the same time, or in completely random orders without worrying about it. And this is with the full compatibility. And then there's like another set of strategies here, which is basically would be backward transitive, or forward transitive, or full transitive. These are kind of like the same as backward, forward, and full. The only difference is that they apply to not just the previous version, but to every single of the past versions. So if you had many mutation on the topic data, that will ensure that the new version, now you have like a version 10, this version 10 will be only allowed if it is compatible with version 1, 2, and 3, and so on. So with all of them. So it's kind of like goes on the entire history of the topic. The format changes instead of just the previous one. I hope that makes sense. It can be very, very tricky to define this, or like to explain what is backward and what is forward, because it's kind of like, it's very easy to get the other way around. But I think that was the easy way that I saw how to display. I hope that was clear. And if you're looking at functions, in function you get many things for free in functions, right? That was the whole idea of Pulsar functions, is to simplify the development of streaming applications. And so you get the whole integration for free, but you also get the schema integration for free. In this case, I'm writing a very simple transformation function. So this is called my functions, and I'm declaring that this function, it is taking a Java object as an input and returning a Java object as an output. So I'm just declaring this object as POJOs, classes definitions. I have my input, which is an integer A and string B, and I have an output, which is a string C. And my function is just taking this input and converting that, doing some transformation and converting that into an output. So by declaring my functions with this is a function of input and output, and this is my implementation. Say that, okay, I'm just like converting that input into a single string and wrapping that into an output object. When I'm submitting this function to Pulsar, basically this will create producers and consumers with the schema type enforcement. So it will ensure that on the consumer side, we are consuming data from this input, so that the topic will have really this format. Otherwise, the function will fail. At the same time, the output that we go on the downstream topic will have to conform to this output definition. So that will be checked again by the broker. So this is a very, very easy way to integrate with to have this end-to-end type safety here, and no surprises at the in production. And finally, like we go back, we have like outside of Java. So the schema is typically like very, very heavy side on Java. There is a lot of Java users that are like very heavy users of the schema registry and the typing. But we have implementation also for all the client libraries. So in all like C++, C, and Python, and Go, you can use the schema, you can declare it, and you can enforce the schema. So in C++, it is a bit on the lighter side, because we don't provide support for serialization and deserialization on C++. That's not an easy task, or like that's not very natural in the way that C++ works to have like this support for it in a true generic way. So we only support declaring the schema. So it kind of like if you are like declare, for example, like you can pass the Avro schema and have your Avro schema definition, and this will basically generate extract the schema here and send it to the broker, and the broker will validate that on the schema of the topic. It will not validate that each message you send it is compatible to that Avro schema. So it's only validating at the producer definition. So yes, you could have a mistake here, because if you publish a random byte after you set the schema to a particular version, that might not be compatible. But at least you can assert that. And this is similar in C. So in C, when you create the C client, you can set the schema info. Again, you pass the Avro schema definition, which is the JSON string, and that's it. So it's very similar to C++, because it's just based on the same implementation here. On the contrary, this is more interesting in Python. So Python is like a type. It's also like a strong type language. So it's a dynamic type language, which has many benefits. But like one drawback is that it is not possible to extract. Like if you have a class definition in Python, you cannot extract the schema out of it in a good way. There's no good approaches there. The other thing is that it is not easy to enforce the schema on this Python object, because you can add fields on an object even if you extracted the schema. So you can basically alter what the schema looks like. So because of this reason, we define a way to programmatically declare your schema. So in this system, so we have like a base Pulsar schema record class, and you can define your class example in this case that inherit for this record, and then we have a set of field type definitions. So you can declare my field A is an integer with default value of 5, for example, or my field B is an integer, and it is a required true or required false. Again, you can have like all these. Essentially, like I'm explicitly declaring my data format here, which is my example. So this is like a very basic example, but you can get as complicated as you need. You can have map, you can have arrays, you can have sub-records that are like all nested and so on. So it gets as complicated as needed. With this, you can basically, we can have a precise schema extraction based on this definition, and you can use that as your class object here. And whenever we publish, so we are creating a producer, and I say that my schema is a say JSON schema of my example for instance here. At this point, I'm getting a producer, and this producer, it is expecting objects of the instances of this example class. So I'm just passing an instance of this example, and which I'm constructing. We say b equal 2 and c equal hello world. The nice thing here is that we can also do is that we can compare the instance that you pass in with the schema definition. So if you take this example instance and you add some incompatible fields, that will get rejected when you try to send, because we can validate that this was not in your original definition. So you are tricking the system here, and we can forbid that. Similarly, on the consumer, like you can subscribe and pass your schema. See, here I define our schema, so you can get JSON schema or our schema, and then you are receiving a message, and that message you receive, it is has an object. So when you say message get value, it is an object which is an instance of this class example. And then you are acknowledging the message. So it is very natural in Python, and this will get validated. So you can have the same definition here that you have in Java, for example. Like if you have like similar Pojo in Java with a similar definition, will lead to the same exact schema definition in Python. So you can interpolate Python and Java and C++ with the schema defined. And last but not least, the Go. So in Go, it is you can declare the schema in a similar way. We don't do the extraction here, but it will be it will get validated. So you can define that this is my JSON schema, and you pass the our definition of that schema. At that point, you can do send and pass these objects, and that these objects will get serialized there as JSON or our. And I hope that was a useful overview, and I'm open to questions. So don't be shy, don't be afraid. Just please ask any question that I might have missed. And I just want to conclude here by say that we are hiring. So if you want to help out build Pulsar, we have several positions open here, and there's a lot of interesting features to build, a lot of interesting problem to solve. So any questions? Okay, if there are no questions, I will close it, but please feel free to reach out to me, and with any questions on the schema or anything else related to Pulsar.
Great. Thank you so much, Matteo.
Thank you. Bye-bye.
Bye-bye.